Okay, hello everybody. Hello. How's everybody doing here today? Hope everybody's doing well. I got this from. All right. Hello, Goldmash. How you doing today? Hopefully you're doing well. Good evening to you. Hopefully you're doing well this fine evening. You good? That's good. Did you happen to take another walk here today? Maybe the weather was nice outside. I don't know what the weather's like over there, but hopefully the weather was nice. All right, we are back. We are back on a Wednesday. Oh, man. Had to wake up like super early this morning, so I'm a bit tired. We gotta get through this anyway, so doesn't matter. Gotta keep on trucking through until we get stuff done. That's the goal. That's the plan. And maybe in the afternoon I'll take a nap. maybe that's what we do. Check this quick. Oh wow. Okay. All right, that works. Yeah, the weather was nice today. Yesterday, it's gonna rain today. Oh, okay, so a little bit of rain on the horizon. Totally understandable. I know where everybody is today. Hopefully, we got some people in the class here. Want to come out to do some stuff? Be like, all right. As I'll just go through this stuff lickety split. Be like, all right, get that done. Bam, bam, bam. Alrighty. We're gonna get started here in just a few minutes. It's actually pretty nice outside here today. Boy, oh boy. I wish I wasn't so tired though. And I got some caffeine next to me and still, man. Ugh. Running on some fumes today. Hey Jess, how we doing today? Morning / afternoon to you. I am running on pure fumes. I got like 3 hours of sleep. Body didn't want to go to bed. I had to wake up in the morning. Had to go to the dentist at 7 o'clock in the morning. And then I came back. Yeah. Whew. Yeah. Jess, how are we doing today? How are we doing today? How's everybody doing today? Hopefully you're not as tired as I am. Surprisingly though, even if I'm tired, I still know how to do math a little bit. Well, okay, maybe I just know how to do the math, period. But Bernice, hello. How you doing? Bernice, good to see you. I hope you're doing absolutely fantastic. Yeah, Jess, I'm tired. I'm not gonna, no two bones about it. I'm just tired. I'm running off of 3 hours rest and some caffeine. I'll probably take an afternoon nap after this class. I'll probably just take a nap because like just gonna be like gone. Nicholas, hello. How you doing? Hopefully you're fantastic here today. I hope you are. Hopefully you guys are doing very well. I promise you today will not be so bad. Promise you today will not be so bad. Today will be a bit easier there. Khadija, hello, good to see you. Glad you could make it. I feel like you did yesterday, Khadija. I feel that's how I feel. A bit tired. Bit tired here. I should say not a bit. Pretty tired. I was here still. No, you were. No, I'm not denying that. Not denying that. I'm running on 3 hours of sleep and caffeine. That's what I'm running on. My body is working pretty slow, but fortunately, the mathematics appear. Even running off of 3 hours of sleep, not so bad, right? I've been in worse conditions, okay, and still learned mathematics. Story of my life, I don't sleep. I can understand that, Brian. Like one time I got into a car accident, and you know, the seatbelt saved my life. And of course, when you get crushed by the seatbelt, you know, your ribs are gonna hurt for quite a while. Mine hurt for like a good 4 to 6 weeks. It was just like, yeah, it was brutal. It was just like I had to teach like that, and every time you took a strong breath, because it's like trying to take in oxygen and stuff. It's like ah. I think I've taught the next day after 2 classes. I've taught the next day after 2 car accidents. Yeah, that's actually true. That's actually true. 2 car accidents I taught the next day. That's what you do. One time was a calculus class, and I was just sore all over because I crashed my car, and I was like, oh, well, that kind of sucks. I was like super sore. Fortunately, I wasn't injured. That's, well, okay, that's a different story. There wasn't a. I had bruises when I got into a car accident. It was a single car wreck, right? So I hit my car into a tree. I had this Kia, and basically I had it for like 8 months, and I ran it into a tree, right, at about 40 miles an hour. Now the thing was is that the problem was is that I didn't have control of the car. When I hit it into the tree, I actually went unconscious behind the wheel. So I was actually, ironically, I was driving on I was in Kansas at the time, right? And I was driving over to, ironically, the Student Health Center. And then I had a seizure behind the wheel. So of course, I can't control the car, and you have a seizure behind the wheel. So I'm like, I guess my foot, I was going like 20 miles an hour, and then of course my foot just hits the thing and hits the tree. This tree was in front of the Fog Allen Fieldhouse, which is like the mecca of college basketball in Kansas. So of course, the student paper picks up on that. I'm pretty sore. I have a lost car. I have to teach calculus the next day. You know, the student paper gets a picture of my car wrecked in front of the tree because that's how I found out what my car looked like after everything is said and done. It has my name on it. Like, has my name, Ali Malik. And then right next to it, it says no drugs or alcohol were involved. And I'm like, oh, guys, you guys done me dirty. Damn that student paper. Oh, man. That was classic. Completely classic. I'm just, you know what, I'm No, they definitely love their basketball. It's just where I crashed the car was right in front of the field house. So I'm lucky I didn't hit the field house. Of course, it was a ways away, but if I had gone onto the grass, I probably would have hit the field house instead of hitting the tree. So, because that was like the only tree in like that kind of radius area there. I didn't become a celebrity for the right reasons. If I were to be a celebrity, at least let it be at least let it be for good reasons, not for crashing my car, man. The next time I crashed my car was when what, on my birthday? Yeah, next time I crashed my car was on my birthday. When I crashed my Sentra. That was on my birthday, and I was actually heading over to Harper for my second job, and yeah, ba-boom, T-boned a Navigator and flipped it over with a Sentra. There you go. Man. Yeah, so if you can imagine a Nissan Sentra hitting a Lincoln Navigator, one of those tanks, you're like, boom. Yeah, fortunately I was okay. I was going like 50 miles an hour. The speed limit was like 55. And there was no way I could stop in time. I hit a Navigator. I T-boned a Navigator with a Sentra, and I flipped over the Navigator. Yes, that happened. You're talking a piddly sedan flipped over a giant tank of an SUV. Yes, that happened. There was no way I could stop in time. Like, literally no way. Like, I'm driving 50, yeah, I'm driving 50 miles an hour down this road, and the car basically was on the side road here, and it jutted out to try and turn left, and it stopped in the middle of this 2-lane street. I'm going one way, there's another way. It's coming from the side. It's 100 feet in front of me. I'm going 50 miles an hour. There's no way the car, by physics, there's no way the car is going to stop in 100 feet. It was pretty much slam on the brakes and pray. And pretty much that's how it went. No way in heck that I could avoid that accident. There was no way out for me. I even looked to the side right before I hit and was like, there's another car right behind it, and I'm like, well, yeah, this is gonna be bad. Then I got out of the vehicle, and then I had to open the door because they were stuck in their Navigator, and so I opened up their back door and got them out of the vehicle. What insurance do I have at Geico? I mean, insurance covered the stuff. That was fine. Fortunate part is that nobody got hurt. Okay, so look, I'd be glad to lose my cars. I don't care about them. Okay, the cars get me from point A to point B. That's great. Okay, but and of course you maintain them. But loss of life, things like that, that's more important. I'm glad that those guys in the Navigator, they weren't hurt in any way. I kind of lucked out because it was a work vehicle, and apparently in the back, it was all padded in the back, and they all kind of rolled around in the padding in the back. I was like, well, that's fortuitous. It was just ironic. So I'm just glad that everybody was okay. That's, yeah. Look, what car do I drive now? I drive a Civic. I drive a Civic right now, Nicholas. Look, Khadija, if your dad cares more about the car than he cares about you, then his priorities are out of order. Okay? I'm just gonna be honest with you. Look, cars can be replaced, dents can be fixed, okay? Things like that can be, paid off with money to fix things. Your life is a completely different story. Your car is more important than you, but put more value into yourself. My first accident, I remember my first accident was I was 16. I had all this hubris. I was arrogant. Yeah, and I remember when I got in my first accident, I took a stop sign too carelessly. Yeah, I remember going to my parents and I just admitted to them straight up and be like, hey, I got into this accident. And, of course, I was pretty emotional about it. I started to cry. I was in high school. I was like, I didn't know really what to do. And I was like, okay. And I remember my parents were just like, I'm glad you're okay. That's what they told me. We're glad you're okay. But what can we do about the car? We'll figure that out later. But we're glad you're okay first, and then take care of everything else afterward. So, look, money can come and go. Look, I've gained money, I've lost money. Money comes and goes, but your life is a one-time thing. So, always value that over the amount of money you make. Always value that. Money can make it easier, money can make it harder. Just depends on how you use it, of course. But you know what? I don't do this. I understand that, but that's his priorities. You can be different in that regard. Like, let me be perfectly honest with you, Khadija, and everybody else here in chat. I'll be straight up honest. Like, I don't do this job for the money. I don't. I make money. It pays for my semi, weird ass lifestyle. But I don't do this job for the money. I do this job because I like it and it's fun, and I do it for the love. And it seems weird. It's like being a math dude, being a math professor instead of a doctor, lawyer, engineer. But at the very least, I'm doing what I like, and that's all that matters. And if heaven forbid, something were to happen to me, at least I could go with a smile on my face, because at the end of the day, I can clearly say with a degree of certainty that I made an impact on at least one person's life. I'm very happy about that, and that makes me very, 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 very pleased. So that was my life goal to begin with. My life goal was satisfied quite a long time ago, but I consider everything else a little bit of extra gravy. I don't set my bar really super high. I don't set my bar super duper high. I said one person because I feel that my valuation is here, and then if I just work my way up, there you go. That's how it is. That's how it is. I don't need super lofty goals to be happy and be satisfied. I'm sorry, man. I apologize. Well, lots of people who are unhappy and lots of people who are poor and happy. Yeah, I mean, yeah. But you could be just, in the middle of the road. Yeah, there's some uncomfortable truths that are out there, Nicholas. Let's not, I'm not going to kid myself, and I'm not going to kid you. There are uncomfortable truths out there that are true that math can show or whatever. But what I will say is that it does, what I will say is that at the end of the day, it's your life. You make of it. It's your life. You make of it what you will. You are individuals. I've treated you like individuals, and I want to see what's best for you as individuals. Like I said, if you walk out of here being more of a independent individual and make your own decisions, then you know what? You're going to be stronger for it. Some of the strongest people I know, are can be relied upon, and solid individuals are people who can make those do that critical thinking and make their own choices for themselves. And I want you to be in that same situation, And you always have to be realistic. You always have to be aware. Mom also have a huge house and luxury car. She showed that dad's family that she's well off. Who cares? I don't care about that. You don't either. I just want to live a quiet, happy life. Live in an apartment for a bit. Yeah. I want to live the life the way I want. Now that I want to. Yeah, exactly. Look, Khadija, my mom was not happy with me when I didn't want to be a computer scientist. I have a degree in computer science, but I've never used it in the time that I got it as a bachelor's degree. Computer science and math go together really, really closely, yes. So it made sense to get both degrees at the same time. But I've never used a CS degree ever since I got it, because it's just my cup of tea. That's not my cup of tea. That's not how I live. That's not how things are done. Man, woman, doesn't matter. Man, woman, doesn't matter. Choose your own destiny. Live the way you want. If it means that you have to get out of the house and you got to work for yourself and you got to make your own money, and because you don't want anybody else you don't want to be under the thumb of anybody else, that's what you're going to do. End of story. I learned that very early on. That's why I got my first job at Mickey D's at 15 years old. Now that's why I got my job at Mickey D's at 15 years old. Now I know Mickey D's doesn't really do anything, but thing is, you listen to what's more. You listen to the circumstances, right? Doesn't mean you don't listen to your parents. It's just like you listen to the circumstances. Not everybody's going to be right for everything that you want to do. If your parents are prioritizing different things, like putting on airs for everybody else, then to me, To me, and I'm not going to speak for you, Khadija, to me, that doesn't matter. Like, none of that crap matters, because it's just crap. It's just, like, showing yourself off with the amount of glitzy glamour and jewelry. Like, I don't care about that. I want to care about something genuine, sincere, something real. You know, I care about those things. When you're genuine, when you're sincere, when you're real, people see that. People feel that. People know what that is. When you just put on airs, people know the difference between fake and real. Like, really. My goal is to be the most coolest person in the nursing home. All right, legit. I ain't gonna complain. If that's who you want to be, that's cool. Like I said, the reason why I got a job at Mickey D's was to get a TV VCR combo. And I never forgot that TV VCR combo. I ain't gonna lie. That TV VCR combo literally changed my perspective and literally changed my life. You're probably wondering, why is a TV VCR combo so important? Because when I got my TV VCR combo, I put it in my room, right? And I would just watch like videotapes of like, I would watch anime videotapes and stuff like that, or TV or whatever. Thing was, is that my parents couldn't send me to my room no more. And I gained my shred of independence. That was my first shred of independence. I bought it myself. They couldn't take it away from me. They couldn't do anything about it. I said, you can't take away something that you own. Like, okay, I may be living underneath your roof, but something I bought for myself, something that I earned for myself. I worked really darn hard for it, working at $4.35 an hour at the time in 1995. I said, this is what it is. Okay. And so that's and then slowly but surely I started getting different jobs, and then I started making my own money, making my own way. I started making, I made some bad decisions along the way. Had to be corrected a little bit, admittingly, but slowly but surely made myself to be more independent over time. Then eventually able to do what I wanted. Much to the chagrin of other people, but hey, you know what? It is what it is. So, there is light at the end of the tunnel. That's true. Do I watch Naruto when it's airing weekly? Why? Why would you watch Naruto when about half of it's filler episodes, my dude? Have you watched Shippuden before? Read the manga, man. It's 700 chapters. It's much better worth your time. Okay. Naruto's good. I mean, Naruto, the story is really good, but man, those filler episodes are just awful, awful things. All right. Oh my gosh. All right. I've already ran over time here. All right. Let's let's get started. I gotta get started with actual material. I'm sorry. I gotta stop going on tangents before we start here. All right. Let's go ahead and get started here. Let's do this. Okay, let's get started today. Welcome back. Welcome back to Wednesday. All right, we're going to pick up where we left off last time. Today, ladies and gentlemen, we're going to be talking about section 7.3. Just talking about parabolas, okay? Parabolas are what we're going to be doing here today, okay? So that is the goal here. Now, you guys have all seen parabolas before, but in this section here, we're going to be looking at it from a slightly different perspective, just slightly. All right, so let's go to the big board. Let's take a look at what we're doing. What are we doing? We're doing this. All right. Okay. So some of this stuff here should be fairly familiar. We can have a stream one day where it's just tangents of different subjects. I know. I gotta go down to business here though, Jess. Otherwise we'll never finish. And if we don't finish, that's very sad. So I know. Being on a Friday. Yeah, great anime though. Watched it over quarantine. Now look, Naruto is a good show. It's just the filler episodes in Shippuden just ruined it for everyone. Just saying. All right. Anyway, All right, so let's look at question 1 here. Question 1 says, what are the standard equations of a parabola? All right, so now what we have here is we've been used to kind of two types of parabolas, you know, kind of one that opens up or one that opens down. In this case, we're now going to have two additional parabolas, okay? We're going to have additional parabolas here, one that opens right and one that opens left. Okay, so let's take a look here at those two guys as well. So here we have two different types of equations. Yeah, I'm not going to talk about Boruto, okay? Not happening, all right? I don't talk about cheap knockoffs. All right? That's all I'm just going to say about Boruto. I kind of dislike Boruto. So it's just kind of nah. It just feels like a repeat all over again. That's really what Boruto feels like. Like, I'm glad you get to see them grown up and stuff, but yeah, I don't really care for Boruto at all. Anyway. If you grew up with Naruto, Boruto's not really good. All right, so let's talk about the equations here. The first equation here is y minus k squared equals 4 times p times x minus h. All right. Again, what we're going to have here is we're going to have these four things here. We're going to have a vertex. We're going to have an axis of symmetry, which we'll talk about here. We're going to have a focus. We've talked about focus before here. Again, in this case, though, because it's a parabola, we're going to have a singular focus. Okay. And we have also a directrix. The directrix here, we talked about a directrix a long time ago. But if you recall here, the directrix is like that imaginary line that kind of cuts the graph in half there. Okay, kind of weird. There. Okay. Guess we'll have to go with that question mark. No? All right. Now, so how's this going to work here when we take a look at these kind of graphs? I want to take a look at the shape of these graphs here based on the table that you see here. All right, so that's what I want to look at here first. Let's look at the shape. All right, so I want you to look at what we have here. Again, you see that y here comes first. You see y minus k squared, meaning you'll have, say, y squared here. The shape says, okay, if p is bigger than 0, then it opens right. Opens right basically means this. This is what it means to be opens right. So this is what the general shape of the parabola is going to look like. Okay. If it opens left, it's going to look like this. Okay, so that's opens right and opens left. Okay, when we talk about now we have parabolas off to the side as opposed to just being up or down. Again, you're already familiar with up or down here. Again, this is opens up. And then here we have opens down. All right, so you probably have seen the up and down part there, but that's perfectly fine. But there you go. All right, so nothing too crazy there. Again, we'll be looking at these four guys here, but it will be important here to note the shape of the graph because of one particular part here. So we'll be going over that example in order to highlight that, of course. Okay, in any case, we have a focus, we have a directrix, that's perfectly fine. Again, I want you to note the focus and directrix here. That both involves P here. Okay, so we have a vertex here, which would be H comma K. Again, the opposites here, just as usual. But again, we're adding by this number P, and we'll talk about how we get this P here. This P you get here from the general form here, which says 4P times whatever. So we need to use that here into finding the focus and the directrix here, and also figuring out which way this graph will open based on what we see. So what I'm going to do here first is I'm going to go ahead and do an example. Okay. Actually gonna so let's just do an example, and we're gonna go through about how to go ahead and graph this guy. Okay. Let's take a look at this. So we'll come back to this information here in just a second. But, let's put one down. Let's go with that. Okay, let's start off with this equation. We'll start off with something simple. We'll work our way up just as we normally do. All right, so here we got y squared is equal to negative 12x. Okay, now our goal here for this problem is to go ahead and graph this parabola and find out some of the key pieces of information. Again, finding out the vertex and the focus and directrix and the graph opening and all that stuff. So first and foremost here, we want to go ahead and figure out what the shape of this graph is. Let's talk about the shape. What's the shape of this graph here? Well, if we're going to know the shape of this graph here, we're going to want to know what P is. Now, I want you to take a look here at this. Okay. Notice that in each of these general forms, we have this 4p on the outside here. Okay, that's what we have here. We have this 4p on the outside here. You notice that we have this number negative 12 here on the outside. Okay. So what we have here is if we want to find out the shape, we're going to set this 4p is equal to this number here on the outside, which is negative 12. We just divide by 4 on both sides, find out very quickly that p here is equal to negative 3. Okay. Now remember what letter also comes first. What letter comes first here is y, or I should say what letter is squared. In this case, the letter that's squared is y. So let's answer this question here first and foremost. P here is negative 3, and y is the variable that's squared, or the letter that's squared. Does this graph open left? Does it open right? Does it open up? Or does it open down? What's the shape of this graph? Does this graph open left, right, up, or down? Based on the table you see there off to your left. Okay, it opens left. Okay, very good. So here, y came first, that's fine. And p is less than 0, so this is going to open left. So again, based on what you know, the general shape is going to look like this. It opens left. So in your mind, if you're going to do these parabolas correctly, in your mind, I just want you to keep this part in mind, okay? This is what I want you to keep in mind, all right? Sorry. All right. All right. This will be important for what we're going to be doing here later, so I'm just want to point this out. Okay. Let's talk about why this is important. Let's go over the steps here on how to graph this guy. All right. Let's go to step number 1. Let's go step number 1 here. I know this is a little out of order here today, but again, I just want to showcase that off. Step 1 here, if necessary, convert the equation into standard form using completing the square. Again, if it's necessary, we're gonna, if we have to, we would use completing the square to actually convert it into standard form. In this case, they already give it to us in standard form, so we're pretty much good to go. Okay, so that's fine. That checks out. Step 2, find the vertex. All right, let's find the vertex here. Remember, the vertex is the point on the graph. Again, at the very tippy top or the very bottom, or again, at the top of the parabola, bottom of the parabola, whatever you want to call it. What is the vertex of this graph? Okay, so let's go back up here for just a second. come back to step 3. Can anybody tell me here, what's the vertex of this particular, with this particular equation? What is the vertex here? What's the vertex you see here? Our general form is y minus k and x minus h, or x minus h and y minus k. What's our vertex here in this case? What do you think, guys? What's our vertex here? What do you think, guys? What do you think? 0, 0? Is that your final answer, 0, 0 there? I gotta know. Final answer, Nicholas. Yes, okay. Alright, so the answer is indeed 0, 0. That is correct, yes. Alright, good job. I was wondering if I'd get you guys 3 days in a row. The first example, I always have the first main point to be 0, 0. I got you 2 days in a row. I couldn't get you for 3. All right. I'm a little disappointed. That's why I didn't answer. Were you going to say 1, 1 again? Were you going to say 1, 1 again, Brian? You going to worry me again? 3 days in a row of 1, 1. I have no idea where you get 1, 1 from. Because then you would have y minus 1 and x minus 1. I'm going to tell you. No, look, you're better than that. You're better than that. Okay? Look, you're better than that, Brian. Like I said, I always try and make it as easy as possible here. But don't say 1, 1. You gotta look at it as it is. Again, you can rewrite it as y minus 0 squared. This is why I do these examples. You gotta, like, get rid of those super bad habits. And you can write it as x minus 0 if you want. So, you can write it like that. And again, you'll get 0, 0 here. Alright, sounds good. Alright, so that is the vertex there. Okay, so we'll come back and use the vertex here momentarily. But let's talk about step 3 here. Now, step 3 here is rather important. Find the focus and the directrix. Okay, so finding the focus and finding the directrix here. Now, we're going to go ahead and take a look here at this. The focus here is given to us as h plus p comma k. All right, so at least get to know this table here, get to know how to use this table appropriately here. Now, we did solve for p here earlier. This is why we went ahead and solved for p here earlier. P here was equal to -3. So basically, we're going to take our x-coordinate and we're going to subtract by 3. So yes, even if p is negative, that's what we're going to do. We're going to just do exactly what it says. We're going to do 0 plus -3. So regardless if it's a negative or not, then I'm going to take that answer straight up. And so we're going to have, this is the focus here, sorry. Again, there's only one focus here for a parabola. So in -3, 0. All right. Okay. So -3, 0 here is going to be what the focus is for this. As for the directrix here, the directrix here in this case is again just x equals 0 minus 3, 0 minus -3, excuse me. So we'll have here actually that backwards, I swear. Our axis of symmetry is horizontal. Why is that? Okay, no, that's fine. No, yeah. All right. Oh, that's right. The directrix has to be. Okay. Directrix is not axis of symmetry. I'm mixing up the two concepts. All right. x is equal to 3 here is going to be the directrix. Again, the directrix here is an imaginary line that is on the outside of the parabola here, kind of in the front of the parabola. So that is the directrix there in that case. I guess I'll put that down. All right, so if you were to actually map out the directrix here, by the way, what would that look like? The directrix, like for this one here, would be kind of like out here. This would be a directrix, like this dotted line, for example. Directrix for like this, for like when it opens up, would be like that. Again, a directrix here is just like that imaginary line that's kind of outside, just a touch outside of the actual parabola, like so. All right. Now, graphing that isn't hard here, but again, just want to showcase that off. All right. Let's go to step 4, though. Let's go to step 4. Now, step 4 here is where things... we haven't actually graphed this parabola yet. We're just finding the pieces here and putting it together. What we do have here specifically is we have a vertex here of 0, 0. We have a focus of negative 3, 0. We have a directrix here of x is equal to 3 using our little table. But the one thing that we haven't found is any additional points here on the parabola. However, you can automatically find 2 additional points here on any given parabola. All right, let's see how we can use that here. Using the focus and 4p, we can determine 2 more additional points on the parabola. Okay, so here's how it's going to work. All right, what they use is what's called a latus rectum. Okay, yes. There you go. All right, so in any case, we're going to go ahead and first establish what 4p is equal to. And so in this case here, 4p, I'm going to take, in this case here, I should actually be a little bit more precise. The absolute value of 4p. I'm going to take the absolute value of 4p, this in purple. That purple, what? I hit the purple key and it doesn't do it. Okay. All right. So we're going to take the absolute value of 4p. Now 4p here again is going to be the absolute value of 4 times negative 3. And this is going to be the absolute value of negative 12, which is going to be 12. Okay. Now, to describe what we're going to do next, I want you to actually see what's going to be happening here. Okay, so what I'm going to do next is I'm going to draw a generic graph of what this is going to look like. I'm going to draw it with the vertex and the focus put in there. So I want to show this off here to get these 2 additional points with this 4p here. So at first it's going to look really confusing, but then once I show you what you'll need to do next, it'll hopefully make more sense. So let's blow this up here. And so we have a vertex here of 0, 0, so that's fine. We know the shape of this graph, it's going to open left. All right, we have a focus here of negative 3, 0, so 1, 2, 3. All right. Some tick marks here. All right, so some generic tick marks here. There we go. Let me mark the. I'm going to go ahead and mark the focus in blue. Okay, so this is where our focus is in blue. Our vertex is here. This is the only point on the graph that we know of so far. Okay. Now, what are we going to do with the focus and 4p? So we do have the focus here at negative 3, 0. We have 4p is equal. The absolute value of 4p here is equal to 12. What you need to do here is you need to divide this by 2. Okay, so that's what you're going to do next, is you're going to take this value of 4p, right? And I guess I need to put this here, so let me put this here. So divide the absolute value of 4p by 2 and move that amount of units from the focus either up or down, either up, down, or left, right, depending on shape of the parabola. Find the additional 2 points. Okay. So, all right, I'll give you. I know I just typed that out there, so let me give you guys a minute to write. Let me give you guys like 20-30 seconds actually to write that down. That's actually important here for this. So. Okay. Let me know when you got that, and then I'll move. I gotta put this on full screen. Let me know when you guys got that, and we'll move forward. Got it? All right. Okay. All right. So, let me show you what's going to happen here. Okay? Very carefully. Got to be a little bit extra careful about this. Okay. So, I'm going to take this 12. I'm going to divide it by 2. That's what I'm going to do next. Okay? So, again, 12 divided by 2 here is going to be 6. Now, you know the shape of the graph here. Okay? So, from the focus here, let me ask you guys this question. This is actually really important. All right, based on you knowing what the generic shape of this graph is going to be, are we going to move up or down to find those 2 points, or are we going to move left or right to find those 2 points? Because what we're going to do here is we're going to start from the focus, and we're going to move either left or right by 6 units, or we're going to move up or down by 6 units. Okay, that's essentially what we're going to be doing here. We're going to move. Okay, good. And in this case here, Lysander says up and down. That is correct. Okay. So I'm going to put this in parentheses because obviously that's not true for every case. Up and down by, in this case here, 6 units. So let's move up and down by 6 units. And then let's see what points that we actually have here, okay? And we'll put that in green. And that'll be part of the graph. So we go 1, 2, 3, 4, 5. We'll have to add one more here for 6. So here, this is a point here on the graph. All right, so that's going to be, this point here is going to be -3, -6. Okay. We also have the point here 0, 0. We know that's the vertex. And then we move up by 6 units. 1, 2, 3, 4, 5. And then it looks like we'll have to add one more. Call that 6. All right, and so we have the point here of -3, 6, +6. So these two are additional points, are 2 additional points that you know for a fact is going to be on that parabola. And then all you have to do is now you have a vertex, you have your 2 points on your parabola, you can go ahead and do the last step here, which is just graph the parabola there with the points found. So let's connect the dots here. We'll put it in orange. yellow or gold, whatever you want to call it. All right, so we'll put this here. Again, you can start here from here, and here. Okay, and this is going to be the general shape of our parabola for this particular problem. Okay, so here we got exactly what we were looking for here. Again, we just put the pieces together. Again, put it in standard form. Need to find that vertex, find the focus directrix. Okay, um, and then of course those two additional points here by doing the lattice rectum thing, and then is just draw that parabola just like so. And that's all you have to do. Okay, so far so bueno. Any questions about that? What's the generic shape of the graph, right? So this is the part where you have to kind of put it together here, Brian. That is, in this case, because you know the generic shape of the graph here is, let me go back here. The generic shape of the graph opens left, okay? We established that early on. So when you know you want to find 2 points, and if we're starting from the focus here, which is on the inside of the parabola, you need to go up and down to find those 2 additional points there. Okay? That's why drawing out the picture is really helpful, because then you don't have to guess. That's why I drew out the picture here to start with, because then that establishes when I get to that point in step number 4, I don't need to guess which way I need to go. I either going to go up and down, okay, from the focus, or I'm going to go left and right based on that generic shape. So that's the way I kind of want you to think and be like, okay, I know what the shape looks like. All right, I'm going left, right, up, and down. Let me look at the generic shape. All right, since I know I'm going to start from the focus, okay. Well, now I'm in this case, like in this example, I'm going up and down. All right, fine. That's all. That's all I need at the end of the day. Generic shapes down. Know what the shape looks like. I know which direction I need to go. I can put those pieces together once I get to that step, and I'll be good. All right. Uh, any other questions? Any other questions so far? All right. Let's go ahead and do another. Josie, hey. Thank you for the hydration station. Appreciate that. All right. Very good. Okay. So hopefully you have this here. I'm going to go ahead and erase this out of existence, and we'll move forward. All right, out of existence. Okay, let's focus on the next problem here. All right, so next problem here that I want to do is okay, let's do sampling. Let's do x plus 2 squared equals negative 16 y minus. Okay, there we go. This one here I kind of made up on my own, so we'll see how this goes. All right. Okay. First of all, let's at least determine here what the shape of this graph is going to look like. What is the shape of this graph? Let's figure that out. Well, we need to first determine what p is going to be equal to. So again, if we're going to determine what p is equal to, we're going to set 4p according to our standard form here. We're going to set 4p, if we have it in our standard form, we're going to set 4p here is equal to negative 16. Again, if we don't have it in the standard form, we're going to have to do a little bit of work to get to that point. In this case, we already have step 1 here. We have our standard form already set, so we're okay. Okay, so that means if we have 4p is equal to negative 16, p here is equal to minus 4. All right, fine. So, you guys tell me, does this graph open left? Does this graph open right? Does this graph open up? Does this graph open down? So you got up, down, left, right. Which way, according to our table, back to our table, which way does this graph open? Does it open down, left, right? Nicholas says down. So p is negative, and we start with x. X is the one that's being squared. So in this case here, p being negative and the x being squared here, that's correct. This opens down. So as a picture here, there we go. That's what it looks like as a picture. Okay, let's go ahead and do the next part here then. Let's do step 2. Okay, so we'll come back and use P here momentarily, but again, going back to here to step 2, we're going to go ahead and find the vertex. Let's find that. Can you guys tell me, what is the vertex? What's the vertex of this parabola? What is the vertex of this parabola? What's the vertex of this parabola? Negative 2 comma 1 says Joseph. All right, very good. That is correct. That's right. Okay, good job, Nicholas. That is correct. Yes. Both of you are absolutely correct here. Negative 2 comma 1. Okay. Again, x plus 2, take the opposite, minus 2. Y minus 1, take the opposite, positive 1. Seems fair. Okay, so that's our vertex. Good. Step 3, let's find the focus and the directrix. Okay. Again, follow the little table we have here. So the focus here is going to be, again, h comma k plus p. All right. So here we have negative 2. Remember, this is our h and k. Here we got 1. We'll put this plus p, so plus negative 4. Our focus here is going to be negative 2 comma negative 3. Okay. And we also have our directrix here. Again, the focus and directrix, to find those, just use the little formulas that we have here in the table. Again, as I said here, make sure you have this at least written down in your notes so you can reference it back. Again, the focus is always inside the parabola, so if you're ever confused, you can always take a look here and you know that it's going to be inside there somewhere. So, okay, here we have directrix is y is equal to k minus p. So, k here is 1 minus negative 3. But y is equal to 4. Okay. Okay, so before we move forward here, are there any questions about how we found the focus and directrix here? Any questions at all about that? Hopefully everybody is okay with that. Yeah, so that table there that I'll post up again, very handy to have here in this instant. Nope. Okay. That works. All right. What did I put? Isn't P -4? What did I put? Did I make a mistake there, Josie? I have 1 plus -4 here. That's fine. And the directrix here, 1 minus... Oh! Oh. Oh. Yeah, this should be -4. You're right. Are correct, Josie. I put -3 there for some reason. That should be... yes, you are correct. Thank you for pointing that out. For some reason, I put -3 there. Maybe I'm kind of thinking too that in my brain. Alright, so this should be y is equal to 5. Alright. I did it over here. I was supposed to do it over here. Alright. Thank you very much. Guys, feel free to correct me at any time, by the way. So, always fine. Alright, let's go to step 4 here. Okay, let's answer this question here. Again, we need to find out the absolute value of 4p. The absolute value of 4p here, again, that's 4 times -4. The absolute value of 4 times -4, that's -16. That's going to be 16. I'm going to take that 16 and divide it by 2. That'll be 8. Okay. Now the question is, are we going to go up and down or left and right, starting from the focus? You're going to go up and down or left and right? Let's answer that question here. Okay, left, right. Okay, very good, right? So based on the picture you see here, right, from opens down, right, you know that's what the generic picture looks like. So you don't have to guess. Again, you're going to go left, right here to find those 2 additional points. And again, the amount of units you go left, right is 8 units, starting from the focus. Okay, so remember, not from the vertex. You're starting from the focus, all right? From the focus. So the focus plays a big role here. So let's put a graph together here. Let's put the points down. Okay, we have a vertex here of -2, 1. We have that. We have a focus here of -2, -3. That's fine. Okay. Now, to go along with that, we are going to go 8 units to the left and 8 units to the right. And I'll put that in a different color. I'll put that in a blue-gray. So let me go 8 units to the right, starting from the focus. So starting from here, from -2, -3. So I go 1, 2, 3, 4, 5, 6, 7, 8. All right, so my first point should be here at the point 6, -3. Okay. And we gotta go 8 units to the left here from my focus. So 1, 2, 3, 4, 5, 6, 7, 8. So right here. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would be -10, -3. All right. And so starting from my vertex here is -2, 1. Just going to now connect the dots here. Let's put that in a color, put that in orange. There we go. And there's going to be our parabola here, again opening down from our initial problem. Should be good to go there. Easy time, easy life. All right, good stuff. Okay, any questions about that second example? Any questions? Nope. All right. And an ope. Nope. No, thank you. All right. Si de nada. Nope. All right. Okay. That's the second example there. I kind of wanted to show off that way. Again, how to tackle those kind of problems. All right. Okay. So let's take a look here at another type of problem. I be the best here. Yeah, that's okay. All right, let's. All right. All right. So I'm gonna blink this out of existence here. We're gonna do. Actually, yeah, I can see how much spaces you. Oh, not a lot. Okay. I can actually continue. All right. All right. Let's do the next one here then. All right. So next example here, you probably can guess here based on what the past two classes have been like. Probably this last example here, at the very least. Let's go ahead and do this out. So the one I think will be okay will be. Sure that I'm actually. Oh. Uh, oh no. Sometimes I'm kind of debating in my head which one I want to do as the example. Two really good problems. Like, which one? So. All right, let's go with this one. All right, so here we get y squared minus 2y plus 12x minus 35 is equal to 0. All right. Now at this stage here, we don't have a standard form, okay? A standard form looks like our last two problems, okay, where we have something squared on one side and we have some number on the outside times something of the other letter. Fine. It is what it is at the end of the day. So it doesn't look like our standard form that we have here from our table. So the goal here, of course, is if we're going to go and convert this into standard form, as the note here says, let's go back to our notes here for a moment. Again, we just need to go ahead and complete the square here. Once again, yes, completing the square, and we can put it into standard form based on what we see here. All right, so that's essentially what we're going to be doing here. Now, completing the square isn't too hard because unlike the last problem where we did like hyperbolas and ellipses, you're not completing the square two times here. You're just doing it once. The only little added twist to this one, though, specifically, is that you have to be careful about what's going on the right-hand side because you want it to make it look like this standard form that you have here. All right, so keep that in mind as we navigate through this problem here, is that, hey, I want it to look like the standard form here, so I'm going to leave that off a little bit here to the left so we can mimic exactly what we want here out of this problem, and then proceed to get all the rest of the information for the parabola and put it together. So what we're going to do here first is, if you notice what's squared here, okay, notice what's squared here. Notice that we have y squared here to start with. So since y is squared, we're going to put all the y guys, we're going to have that y squared, we're going to make sure that all those y guys are going to be kept on one side of the equation. Make sure that's positive y squared, by the way, or positive x squared if it was x squared. And then we're going to move everything else over to the other side. Okay, so we're going to just subtract by 12x, and add by 35. So we don't want it here. We want that over to the other side. I'm gonna just shove it all over there because we'll deal with it on that side of the equation. So that is a very light color, not the color. All right, there we go. We get y squared minus 2y, that's fine, equals minus 12x plus 35. Okay. So nothing going untoward here, just pretty normal stuff here so far, but still a little bit more to go. Okay, next, what we have to do is we're now going to go ahead and complete the square using this middle term, this middle coefficient for y. All right. So we're going to take, again, negative 2 divided by 2, square it. We get negative 1 quantity squared. That's going to be 1. Okay. We're going to add by 1 here on this side. And what should I do on the other side? Remember how completing the square works. What should I do on the other side here? Okay, I got a plus 1 there. Okay, good. I added 1 on the left. I'm going to add 1 on the right. All right, good. That's right. Okay, good. Let's take stock in what we have. All right, so taking stock in what we got here, we got y squared minus 2y plus 1 equals negative 12x plus 36. All right. Again, I don't have it exactly in the form that I want, but we're very close to getting it done. Just one more step here. All right, so now the last step here, of course, what's the purpose of completing the square? It's for us to make sure that this is easy to factor. So we can factor y squared minus 2y plus 1. That's going to be y minus 1 quantity squared. Again, you know that because that's what it always factors to when doing completing the square, whatever that number is after you divide by 2. And let's take a look at the right-hand side. Now, the left-hand side isn't hard. That's how we set it up here using completing the square. On the right-hand side, on the other hand, though, we do want to factor out something specific. Specifically, and it doesn't matter what the number is, you are going to factor out this number here in front of that variable. So that coefficient of, if that's x or y, it doesn't matter, have to factor that out. So I will put a word of warning here. We're going to factor out a negative 12 by default. Okay. So I'll put a warning sign here. Must factor. You don't get to pick and choose by coefficient. Of the variable on the right hand side. All right, so even if this was super ugly, for example, if this said, say, negative 7, all right, let's say this was like negative 7x plus 36, I would still factor out by minus 7. Yeah, admittingly, I am going to get a fraction as part of the thing, but that's just part of the deal, okay? So no matter what, I have to factor by that coefficient. I don't have any way to get out of it, right? Even if it's a fraction, it's a fraction. It is what it is, all right? Just because you don't get nice numbers, it doesn't mean get not nice numbers doesn't mean it's wrong. Okay? Doesn't mean it's wrong at all. I'm forced to factor whatever that number is. In this case, minus 12. So if I factor out minus 12, that leaves me with x minus 3. Careful about that, by the way. Sign changes. Factor out a negative. Okay, so before we move forward here, are there any questions about these particular parts, especially that last part there? Any questions about that? I just want to make it crystal clear about how we can come up with that. So, you know. Oh, all right. Yeah, no, I'm being very specific about it, but again, it's the biggest point in these problems here. This is the biggest point of contention that people have. They often forget about that part. Okay, now starting from here, we can go ahead and do the rest of the problem. Okay, because this is basically all we've done here. Essentially, is step number 1. Okay, so we went ahead and did step 1 here. This is all step 1. All right, all of it. We have it in a standard form that we can acquire information from now, and now we can start putting 2 and 2 together. So let's do step number 2. Let's try and finish off this problem now. All right, so step 2 here, let's find that vertex. What is the vertex of this parabola now? We'll find P here in just a second, by the way. So what's the vertex of this parabola? Oh, one of those is true. I agree. One of those is true. Let's do a poll. Poll time. I need excuses. Radio button, what you think is the vertex? So far we have a few people there. Okay, so we got 2 people with 1 3, 4 people with 3 1. Okay. All right, 3 people with 1 3. All right, so 5 people say 3 1, and the 3 people say 1 3. Let's go ahead and take a look at what the answer is. Is true? One of those 2 answers is correct, and the answer is going to be 3 1. That is the correct answer. You fell for the trap, Lysander. That is true. You did. So Brian, your answer was correct. That is true. Okay, 3 comma 1 here. Notice that 3 here goes with X, and that 1 goes with Y. Just because it's written in that order, Y coming first and X coming second, doesn't mean that the vertex is going to be written in that fashion. Careful about that. Okay. So, yes, you're trying to read left to right, but you gotta see the forest for the trees. That's why I asked this question, because it's like, oh, that's the trap card. Gotta go over them traps. Them traps are very important to make sure we don't step on again. So the reason why I know that is because I fell for the same traps before. So, you know. Thank you for the hydrate, Joseph. I fell for the same exact traps back in the day. I know how it feels. Not fun. So I guessed? Okay. I don't know what you guessed, so We'll go with that. All right. Let's go to step 3. All right, step 3 here. Let's talk about the shape of the graph here. All right, so just wants to hydrate. Sure. Let's talk about. Thank you for the hydration. Let's talk about the shape here. Does this parabola open up, down, left, right? Tell me, what's the shape of this? What's the shape of this parabola? You think? Let's find out what P is. What would you set 4P equal to? We'll find out the shape here in just a second. What would 4P be equal to here? Let me ask that here, because that's what we need to find. We need to solve for P, because that's going to be a lot for what we're going to do to find the focus and directrix and all that jazz. So what should 4P be equal to here if we're going to solve for P? We have our general equation up there, y minus 1 squared is equal to negative 12x minus 3. Fine, that's true. It should equal minus 12. That's correct, Brian. All right, very good. All right, excellent. That's right. So we want that equal to minus 12. That's correct. All right, very, very good. So we want to go ahead and solve for P here. P here is going to be minus 3. Okay? So 100% agree. Now that we've established P here is minus 3, what's the shape of our graph? Is it opening up, left? Opens left. Okay. Good, good, good. All right, getting used to that table. Good. Exactly what I want you to do. Open left, right? So again, it's going to look like this. Okay, fine. Now know the generic shape of the graph. Now know what P is. Fine. Good. Let's go to step 4. Wait, we're not at step 4. What am I doing? I forgot the focus and directrix. Yeah, I still gotta find that. Nope. That's me. Nope. Alright. Let's find the focus here first. Okay, so according to our guy here, our focus here is h plus p, comma k. So again, we have our h and k here from our vertex. We have a 3 plus negative 3. Comma k, which is, so that's going to equal 0, comma 1. That's our focus. And our directrix is, what's our directrix here? X equals h minus p. So x equals h, which is 3, minus negative 3 is our p. So x equals 6. Okay, fine. All right. So one thing to note here is that the directrix, at least where it stands, is always the same amount of units away than the focus. So if the focus is 3 units away, going to like the left from the vertex, then the directrix is 3 units away, going to the right from the vertex. I'll show you what that looks like here in this particular guy. So if I were to graph this here, what do I mean by that? Let's just look at it from a physical point of view. The vertex here is 3, comma 1, so it would be right here. In order to get to my focus here is at 0, comma 1, so I go 1, 2, 3 units to the left to get to my focus. If I want my directrix, x equals 6, I go 3 units to the right because I know that this graph opens left. The focus is on the inside of the parabola, the directrix is on the outside of the parabola. So this is where my directrix is. Okay, and so that's 3 units to the right is the directrix and 3 units to the left, in this case, happens to focus. So that's basically how it works, at least in terms of instances. All right, but in any case, we need to go ahead and find out our points. Okay. Okay, so let's focus on our points here. Again, we need to find out the absolute value of 4p. So that's the absolute value of 4 times negative 3. The absolute value of negative 12 is 12. Okay. What do I do with the 12? All right, so let me stop there here. What do I do with the 12? What am I supposed to do? I don't know what we do. What do we do with the 12? Divide by 2, okay. All right, fine. So I get 6. All right. So I got 6. Now what? Tell me what I got to do with that 6. Agree. Totally agree. 12 divided by 2 is 6. Fine. No problem. Now what? Comes after that. Up and down by 6. Up and down by 6. Up and down by 6 from where, Brian? So I agree. You have to go up and down. Okay. So I'm going to agree up and down because that's the shape. From the focus. Okay, very good. That is correct. Okay, so starting from the focus here, we know the general shape here, so we know that this is the focus in here. We're going to go up and down to get to our 2 points. So let's start from the focus here, which in this case was 0, 1. So this blue point. We're going to go up 6 units. We're going to go down 6 units. So we're going to go 1, 2, 3, 4, 5, 6. So this point right here, which is going to be 7, 0, or no, other way around, sorry, 0, 7. All right. We're going to go down by that, so this is 0, 1. Go 1, 2, 3, 4, 5, 6. We have this point right here. We'll put it in green. That's going to be here, it looks like negative 5. Negative 5, 0. Okay. And then we just play connect the dots after that. La da 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 da. Da da da. What did I put? Oh, man. Why am I doing that? Man, why did I confuse that? Yeah, thanks, Brian. You're right. I made the correction up there, and then I did the same mistake anyway. I'm such a dumb. All right. Yeah, all right. There we go. There we go. Got it. Perfect. All right. And there's our parabola here for this problem. I'm prone to make mistakes sometimes, so I have no problem with that, though. To err is human, so not a problem whatsoever. Right, any questions? Any questions about parabolas? Parabolas. Parabolas are super useful in real life, so yes. Parabolas used everywhere in real life, so 100%. This is something that actually is very... Did you take into account Skibby's Law? I don't think I've heard of Skibby's Law before. Look that up. Never heard of that before. What is Skibby's Law, actually? Look that up. That no idea what that is, Rookham. No questions on your end? Okay. I hope you understand at least maybe one part of it, Golmash. Maybe one part. You finished with examples? That is the last example that I wanted to show off here, at the very least. For these type of problems here. In effect, that would be the end of section 7.3, at least for what we want to do. Section. You guys can ask me whatever you like, so ask me any questions that you'd like if you have any. But you know, that's what I wanted to do here, at least for this section. Be doing let's see here. Check. All right. Brian's like, I want to get the heck out of here. Yeah. Yeah, so that'll take care of it for today in terms of any of the material there. Yeah, work. Okay, that's fair. That's fair. I know you work for the city, so I know they're pretty demanding. So completely understandable. Completely understandable. Any other questions? Any of the questions you guys have? Anything else, guys? Anything else whatsoever? Again, what we're going to be doing here tomorrow is we're going to be going ahead and doing chapter 8 here. So we'll be starting a little bit of chapter 8. All right, so that is going to be what's on the docket here for tomorrow, is section 8.1. And so we're going on the last couple of sections here. We're doing 2 sections from chapter 8. And then that will be it for the new material. So remember, tomorrow will mark 2 more weeks left in the class. So just to let you know, 29th is coming around. Tomorrow will be 2 weeks left in this course. Okay? Thoughts on Boruto? Boruto is boring. So, no. Just no. I read the first few chapters. I'm like, oh, yeah. Let's rehash the entire story of Naruto again with the same stuff. Like, okay, yay, go team. There are very few authors who can get away with the same kind of story, and not have the same kind of criticisms. So there are very few authors who can get away with that. Like a good example of an author who did a very good example of an author who did 2 series that had the same issues as the person who did Fairy Tail, right? So if you watched Fairy Tail before, and then you look at his previous works, which are like Zatch Bell, and I think Zatch Bell was one of his previous works, and I think Rave Master was his biggest previous work. So, yeah, you'll notice like the same kind of story and whatnot. So there you go. You think we'll finish each section of chapter 8 in one day? Chapter 8 may be done in one day, yeah, possibly. It just depends how fast we go over it, so. You did. No, nobody else. You did Gold Mash. Will Naruto be on the exam? EGA. Will Naruto be on the exam? Naruto certainly will be on the exam, EGA. I promise you, Naruto will be on the exam. In fact, I'm just going to make the test like maybe 500 questions, and about 450 questions to 475 questions will be complete filler, just like the anime EGA. That's exactly what it's going to be. All right? I promise you. just point out every single little detail that was just completely unnecessary. Yeah, you got, man, you can study. Look, go study Naruto. It's fine. You could say like, oh yeah, how do you spell Ichiraku Ramen? That's fine. And if you need to do that, that's okay. If you can spell Datebayo, you go ahead and say that. May not be here Tuesday since your birthday. Watch recording. Respect, Nicholas. Respect. What anime am I watching now? I'm watching Welcome to Demon School Iruma-kun. And so I'm a spider, so what? So there you go. What anime do you regret watching? Oh, oh, Jess. There is an anime I do sincerely regret watching. There's two animes I regret watching. One of them for the lulls, and one of them because the ending was so bad that even haunts me to this day. I think to this day, the anime School Days is probably the one anime I sincerely regret watching the ending for exactly how unbelievably the unbelievable way that anime ended was just absolutely bananas. I can't even describe it to you on this stream because of just how bad it was. Like, I don't even know if terms of service is even a thing when it comes to the end of that anime, because it just absolutely floored me. I think it absolutely floors everybody. It's the bad end route. It's not. It's a really bad end. Thoughts on Attack on Titan? Thoughts on Attack on Titan? Yeah, I haven't seen the. I watched it, and I do sincerely like they're splitting up that last season into two parts. I really like the build up. It has been a joy to watch. It has definitely been a joy to watch Attack on Titan, and I really hate Gabby because everybody hates Gabby. I'm just gonna say it. I'm just gonna say it, everybody. Everybody hates Gabby. All right. If you hate Gabby, you're in my camp. All right, because Gabby is annoying, and she is like, I'm glad she got the crap kicked out of her a little bit. It was that was kind of satisfying after like watching her survive for like 3 episodes. 4 episodes of no consequences to your actions about acting absolutely like a madman. I'm like, oh, I've got no consequences. I'll just stab people like crazy because I'm a kid. Like, no, get slapped. Get slapped, you stupid kid. Okay, you shot somebody. Yeah, you met people who like that. You shot somebody, and the people who were associated with her absolutely wrecked you, as was appropriate. Like, man. Although I have to say the Armin Eren standoff was really cool. That was a really cool scene. Just like absolute Armin got absolutely destroyed. But it was one of those really tense scenes that it just sets the tone for the second half. It really does. Love Attack on Titan is so good. So good. Great storytelling. Mercy. All right. Well, if there are no more questions here, I don't know if there are any questions, to be honest, but no, you know how it is. All right. If there are no more questions here, ladies and gentlemen, let's go to the chatting screen. All right. All right, so I want to thank you all very much for coming on out here to the stream today. Thank you so very much. You guys are absolutely fantastic, okay? Absolutely fantastic. Thank you so very much. We will be back on here tomorrow, okay? I know you're still here. Fine, I'm just saying my goodbyes. We'll be coming back here tomorrow, same time, same place. All right, at noontime here. And we'll be going over the last chapters here. We're going on the last maybe section or two in Chapter 8. So that is on the docket here for tomorrow. And if we don't finish tomorrow, then we'll obviously finish on Monday with Eddie and all new material. All right. All right. So that'll take it for today, everybody. Thank you so much again. I love you all. Thank you for making this exciting. Thank you for making this fun. All right. And as always, everybody, stay safe, stay healthy, but most importantly, stay sane, everybody. All right. Have yourself a wonderful day. All right. And night. Take care, everybody. Have a great one. We'll see you later. All right. Bye. Bye, everybody.